Okay, guys, part 2 of the Chapter 8 Circles quiz review. Let's continue forward. So starting with numbers 21 through 26 on this page here, this is all of the segments. Okay, so notice you don't see any degrees, no degree symbol, no angles, no arcs. These are all segment lengths. So this is the PP wee wee wet problems. Okay, all right, so this one is PP, part times part. So we're going to multiply. We've got 15 times x, so it's going to be 15x is going to be equal to that part times that part, 10 times 12. So we have 15x is equal to 120 divided by 15, and we get x is equal to 8. Okay, the part times part PP problems are quite easy. 22, PP wee wee or wet. Okay, this is wee wee, whole times exterior equals whole times exterior. WE equals WE. All right. So remember, the classic mistake here, guys, is a lot of students will say, okay, if I'm looking at the 8 here, I'm looking at the green exterior piece. A lot of students will say, okay, the exterior piece times the whole piece, and they like to say 8x. This length, guys, is not 8x. Think about, I've got two different pieces of string. I've got a green piece of string that's a length of 8, and I've got a red piece of string that's a length of x. To find the whole length of the string, I got to add the green piece plus the red piece. Okay, so when you multiply the exterior piece times the whole, it's going to be x plus 8. Okay, the whole length. All right, that's going to be equal to the other exterior piece, 9 times the whole green plus the red. Okay, so that's going to be 9 plus 15, the whole piece. All right, so when we distribute here, we've got 8x plus 64 is equal to 9 plus 15 is 24. Yeah, so we have 8x plus 64 equals 216. Subtract 64 from both sides. 8x is equal to 152. Divide by 8. And we get x is equal to 19. Okay, move on to 23. PP wee wee wet. This is wee wee. How do you guys know the difference between wee wee and wet? Okay, wet has a tangent. Okay, 25 is wet. How do I know I have a tangent? This line is touching the circle in one point. These are just two segments here. Okay, we don't have any tangents. So that tells me that this is wee wee. All right. So once again, I'm going to, for sake of time, I'm not going to color code each of these pieces. All right, if I'm looking at the top piece, the exterior piece is 7. The whole piece is going to be 7 plus 11. Down at the bottom, the exterior piece is 6. The whole piece is x plus 6. All right, 7 plus 11 is 18. 7 times 18 is equal to, distribute here, 6x plus 36. 7 times 18 is 126, equals 6x plus 36. Subtract 36 from both sides. 6x is equal to 90. Oops. 90 divided by 6. And x comes out to be 15. Okay. 24. PP wee wee wet. Okay, this is wet because we have a tangent here. Alright, so it's going to be wet. WE equals tangent squared. Whole times exterior equals tangent squared. Okay, so the exterior piece is whole times exterior, guys, but I always put the E first. Okay, WE, EW doesn't matter. I always like to put this outside piece first because you're always going to have to distribute when one of your whole or exterior pieces is an X. So I like to have this guy out front first. And then the exterior piece is 9. The whole piece is what? X plus 9. And that's going to be equal to my tangent squared, 15 squared. So now I'm distributing. 9x plus 81 is equal to 225. And let's subtract 81 from both sides. 9x is equal to 144. Divide by 9. and we get x is equal to 16. Okay, 25. We already said this is wet. I have another tangent here. But now notice, guys, whenever you have the tangent or the exterior piece as the variable, you know you will end up with a quadratic. Because if this were an x, I'm going to be doing x times x plus something else. Anytime you multiply x times x, you're going to get an x squared. So I already know without working anything, I'm going to have a quadratic because I got an x squared in here. So the exterior piece, and this is wet, whole times exterior equals tangent squared. So the exterior piece is 12 times 12 plus 15. And that's going to be equal to my tangent squared, x squared. Okay, so this is going to be 12 plus 15 is 27. 12 times 27 equals x squared. So we have x squared is equal to 324. And yes, technically this is a quadratic, but I just take the square root. This is square root method. Take the square root, and x is equal to 18. The only time you have to factor, guys, is when you have a squared term, a middle term, the ax squared term, the bx term, that middle term, and then c, the constant, okay? So in this case, I just had x squared equals a number, so we just take the square root of both sides. Okay, oh, here we go. I see an x outside. That's what I was just talking about. I know before I get started, I'm going to have a quadratic. Okay, so if I look at the top piece, the exterior times the whole piece, x plus the 3, is going to be equal to this outside exterior piece times the whole piece, 4 plus 6. So when I distribute here, x times x, you got to remember to add those exponents. That's the product rule. X squared plus 3x equals 4 times 4 plus 6 is 10. 4 times 10 is 40. All right, so now remember this is a quadratic, but remember I got to have it set equal to 0. So I want to subtract 40 from both sides. So now I have x squared plus 3x minus 40 is equal to 0. Okay. So now I've got my classic quadratic equation in standard form. So I'm simply looking to see if I can factor it. First of all, if we go through a hierarchy, can I pull out a GCF? No. Is this a special case? Can I take the square root of 40? No. Number 3, can I do the square root method like we did on the previous problem? No, because I have this middle term. When you have a bx term, 3x, that middle term, you cannot use the square root method. Then we go down to number 4 on the list, which is see if I can factor when a is 1. A is 1. Okay, there's no number in front of x squared, so that's a 1. So that means that I can try to factor it. So I'm looking at this number here. I'm trying to see what are the factors of negative 40 that add to positive 3. Okay, so the way I approach this is I look at that number, I say, okay, what are the first 2 numbers that pop in your head when you think of 2 numbers that multiply to give you 40? Well, obviously most people are going to say 4 and 10. Okay, well 4 and 10 somehow get me to a 3. If I add those numbers or subtract those numbers in any combination, will I somehow get to a 3? No. All right, so what are the next 2 numbers you think about with 40? I think of 8 and 5. Oh, 8 and 5 are 3 apart. Yeah, somehow I can get to a 3 with using the numbers 8 and 5, okay? But this C term is negative. So that tells me when the back term is negative, one of my factors has to be positive, one of my factors has to be negative, okay? So the question is it positive 8 and negative 5, or is it negative 8 and positive 5? And the sign of the middle term will tell you that. The sign of the middle term is the sign of the bigger number. Since 8 is bigger, my factors are positive 8 and negative 5. Those will both multiply to give me negative 40, and they will add together to give me a positive 3. So this simply factors as these 2 numbers, x plus 8 times x minus 5. It always factors into 2 binomials. Okay, and then what do we have to do with these signs? Flippy flip. I got to flip the signs. So I get negative 8 and positive 5, but I'm still not done because I got to go back and plug in these answers and make sure I don't have a negative length. Well, if I've got a negative 8, x is negative 8, I can't have a negative length here, so that doesn't work. So the only answer that works is 5. Okay. All right. Almost home, guys. Almost home. All right. Here's another kind of toughie. This is another wee-wee problem. I don't see any degrees, no measures, no arcs, no angles, so this is a wee-wee problem. I see an x on the outside. Okay, I already know I'm going to have a quadratic before it's all said and done. Okay, so let's start with this piece on the left. 4 times the whole piece, 4 plus 6, is equal to this outside piece, which is x minus 5, times the exterior piece is x minus 5. But what is the whole piece? I've got this green piece, this 3. I've got the purple piece, which is x minus 5. If I add these together, then I've got to multiply the exterior piece, x minus 5, times both of these added together. So this is x minus 5, the purple piece, plus the green piece. I've got to add those together, which, yes, that means I'm going to have to combine my like terms. 4 plus 6 is 10. 4 times 10 is 40. I'm going to leave this for the time being, x minus 5. Let's combine our like terms over here. Minus 5, negative 5 plus 3, x minus 2. Alright, so now, what do I do with these two binomials? I am going to FOIL. I've got to FOIL this out so I get a quadratic. Okay, so 40 equals first, x times x, x squared. Outer, x times negative 2, negative 2x. Inner, negative 5 times x, negative 5x. Last, negative 5 times negative 2 is a positive 10. Okay, let's combine our like terms. So 40 equals x squared, negative 2 apples minus 5 apples, negative 7 apples, plus 10. I want it set to 0. So let's move the 40 to the other side. And so I will have x squared minus the 7x. 10 minus 40 is negative 30. And now that's set equal to 0. Okay, so what are the first two numbers that pop in your head for 30? 3 and 10. Are those 7 apart? Will 3 and 10 somehow get me to a 7? Yes, they will. Okay. Once again, this back term is negative, so it's either negative 3 and positive 10, or it's positive 3 and negative 10. And the sign of the middle term determines the sign of the bigger number. So since the middle term is negative, the bigger number has to be negative. So it's 3 and negative 10. So the two binomials will factor as x plus 3, the positive 3, and x minus the 7. Or excuse me, x minus 10. Last step is flippy flip. X is equal to negative 3 and positive 10. But I got to go back and plug it back in. Okay. When I plug in negative 3 minus 5 is a negative 8. So once again, that doesn't work. Okay. I can't have a negative 3. Okay. If I plug in a 10, 10 minus 5, that does work. Okay. That gives me a positive number. Look at what the question is asking for, guys. Look at what it's asking for. They did not ask you to find x. They asked you to find the length of SU. Okay, so when I go back and plug all this back in, I'll say if x equals 10, then SU will be 10 minus 5 plus the 3. Okay, 10 minus 5 is 8 plus 3, so SU is actually equal to 8. Please don't miss that tomorrow, guys. Look at what they're asking you to find. Okay, 29 and 30, I love these problems. These are so much fun. Find the perimeter. Okay, so you'll notice that all of these lines, they're all tangents. Okay, I'm going to do these in different colors. So I know that this purple line and this purple line, tick, tick, they're the same. I know that this green line and this green line, they're both tangents, double tick, double tick. I know this red piece and this red tangent are the same, triple tick, triple tick. And let's go blue. That piece and that piece are the same, quadruple tick, quadruple tick. Okay, so this is just kind of like a little puzzle. We got to go around the circle, go around the quadrilateral and find each of these pieces. Let's start with the green. If this piece is 14, this piece is 14. If this red piece is 11.6, this red piece is 11.6. If this blue piece is 8, then this blue piece is 8. But now, how do I find the purple pieces? Well, I've got this whole length of 20.7. So to find the purple piece, I just do 20.7 minus 8. And that gives me 20.7 minus 8 is 12.7. Okay, so this purple piece is 12.7, which means this purple piece is 12.7. Okay, so now I can just simply go around and add up all these numbers. If you want, you don't have to add the 8 and the 12.7. We've got this whole length here, okay? But just for sake of ease, I'm just going to add up all these numbers. Okay, so I'm going to add up perimeter is equal to 14 plus 12.7 plus another 12.7 plus 8 plus another 8 plus 11.6 plus 11.6 plus the last 14. You add all that up in your calculator and you should get 92.6 for the perimeter. Okay, alright, so let's move on to another one. So this is maybe even a little bit easier because we have triangle. Okay, there's a green piece, there's a green piece, tick tick. There's a red piece, there's a red piece, double tick, double tick. There's a blue piece, triple tick, triple tick. Okay, so let's go start labeling stuff. If the blue piece is 12.4, that blue piece is 12.4. If the blue piece is 12.4, then to get the green piece, I need to do 26.4, the whole piece minus the blue piece. 26.4 minus 12.4 is equal to 14. That means this green piece is 14, which means this green piece is 14. And if that green piece is 14, to find the red piece, I got to do the whole 22.5, the whole piece minus the green piece. 22.5 minus 14, and that gives me 8.5. So that red piece is 8.5, which means this red piece is 8.5. Alright, so now here we already have two of the full lengths, so really all I need to do is add those two big numbers, and then I need to add this blue piece and that red piece to get the whole perimeter. So perimeter is equal to the red piece 8.5 plus the blue piece 12.4 plus the two whole lengths, the 26.4 plus the 22.5. Punch all that into my calculator, 69.8. Okay, last thing is just vocabulary, guys. You've got to know what each of these lines are called. Okay, point G. That's a tough one. Center. This is all from day one in the packet. FH. Okay, this guy. All right, it's a chord, but it passes through the center. I'm sorry, I read that wrong. I was looking at the next one. I skipped GE, sorry. GE starts at the center and goes to the outside, so of course that's a radius. All right, FH goes through the center, it's a chord, so that's a diameter. Let's let my camera refocus. IJ, okay, IJ stops and starts on the circle. That is a segment, that's a chord. CD is a line. How do I know it's a line? Those have arrows, these do not. So if it doesn't have arrows, it's a segment. If it has arrows, it's a line. So CD is a line. It doesn't touch the circle in one place, it touches the circle and goes to the circle in two places. Okay, so that is going to be called the secant. AB, okay, AB is a line, it's got the arrows, but that one does touch the circle in one spot, so that's a tangent. Point K, that's that spot right there, point K. It's on the tangent, so that's the point of tangency. Okay. The bottom, they ask us to provide two of each of these, major arc, minor arc, semicircle. Remember, guys, major arc, you need 3 letters. Because if I just say arc HE, I don't know which one you're talking about. Are you talking about this little HE, or are you talking about H all the way around to E? Okay, so if it's only 2 letters, that's a minor arc. 3 letters for a major, 2 letters for a minor, and for a semicircle, I also need 3 letters. And that does matter. If you just say semicircle FH, I don't know which one you're talking about. I don't know if you're talking about the top one or the bottom one, and that might matter depending on the problem. All right, so give me 2 major arcs. I need 3 letters. Something that's larger than 180 degrees. Well, let's see. What about FDK? What about that one? F to D all the way around to K. That works. And guys, there are going to be a lot of these, so I'm just going to list a couple. Obviously, there are more than one correct answer. And then I'll also have HFE. So if I start here, H, all the way around to F, that's a semicircle, then all the way back around to E. That's almost a complete circle. So arc HFE, that's a major arc. And of course, there are a lot of other ones. Minor arc, I just need 2 letters, something less than 180 degrees. Okay, KJ, this little piece right here, that's a minor arc. KJ. IF, this little bitty one right here, that's a minor arc. IF. Shoot, HE, ED, HD, IK, IJ, any of those would be fine. Semicircle, if we go on the top side, I would say semicircle FKH, FKH, or I could say FIH, I could say FJH. You can skip letters. I'll choose FKH, that's fine. And then the bottom semicircle, HEF or FEH. Forwards or backwards, it doesn't matter. Okay, so that's it, guys. That's an hour's worth of video. A 40-minute video for part 1, a 20-minute video for part 2. So if it took me an hour to go over a quiz review, that's why I was saying in the first video, y'all need to study for at least an hour. This is tough stuff. It's a lot of information. Please, please, please study and be well prepared when you walk in the door to your classroom. Hope you guys enjoyed both of these videos, and I wish you much luck on your quiz. We'll see you on the next one.